Hi, welcome to our video. In this video, I will be sharing the difference between different calculation modes that Chemstation provides for you when it's come to calculation. Right. So before I get started, please subscribe to my channel. I really thanks for your support. Right. So let's get into that. We have a total of 6 different calculation modes, and in this video, I explain one by one. And the way I'm going to show you is I will generate report in Chemstation, and then I perform the same calculation as well so that you can compare. Then you know what's going on with that kind of calculation mode, right? Okay, so let's first get into the first one. Go to quantization setting over here. Okay, the first one we will try is percent. So what does it do for percent report is, let me print the report out. Okay, let me maximize this one. So, okay, so you scroll down here for the percent report. What the software does is actually we just perform the convert the error counts to the percentage of the errors. So what does it do? It will just take this error count from here. Let me copy this value, and then I'm gonna put this one to CO here, and then you have this methane. Copy again. I put it here. Then you have the CO2. Yeah, put it here. All right. Then you want to have the sum of this, so that would be sum of this 3, right? And then what the report does, it will actually just take the error count from here and divide by the total error counts. Then, right, so that is 28.32%, and it will be the same thing for this one, and then divide by this one, the same thing for this one as well, and then divide by this one, right? That's how the report will perform the percentage report for you. Let's compare the result. So we get 28.32 and then 54 and then 17. There you go. Right. So that's one thing that I want you to note for this one, and because the software will calculate this percentage based on the total error count from here. So let's put into the situation that you have. Let me close this. You have an unknown peak somewhere, and for some reason that peak is iterated. So let me demonstrate that. Okay, let me go into iteration, and I just draw like a manual iteration somewhere. Let's say you have an unknown peak somewhere here, and for some reason it was iterated and you didn't notice of that. And when you print the report, what will happen is, okay, so down here you have one unknown peak appearing in a table over here, and because you have an unknown peak over here, the software will perform the calculation for all of these peaks. So let me plug this number into this S cell, and then this is the unknown here. I have the sample error here as well, and then for the sum, it will be the total of all of this. So that will be on the way to an H9. All right. So it will be the same over here. So that this will be this one divided by the value. Right. So let me convert this one to percent. All right. There you go. So you have you see that the numbers have been changed from just now it was based on only these 3 picks, but now it will be based on 4 picks. So that's why you want to take note of if you want to choose this kind of report, you want to make sure that you have no unknown picks in your chromogram, only those picks that you want to iterate, right? All right, so that's the first report. The second one the software provides you is, let me close this one. Okay, let's go to specify report and quantitation setting. The second one, the ESTD, stands for external standard. So what does it do? It's basically very simple. Let me print the report. Okay, so what does it do? Basically, it's very simple. That it will take the error counts from the sample and then multiply with the response factor column. The response factor column are in fact in this in your calibration table. So let me do this. I'm going to copy this number over here so that it will be the same numbers over here. So let me show you that. Okay, so let me zoom in a little bit more. There you go. So CO 4.5909. There you go. And then CS4 is 4.5. There you go. And CO2 4.59, something like that. So I'm going to copy this number and perform a calculation for you. Okay, this will be a response factor for CO. I put inside here calibration response factor. Then I have the response factor for methane over here. Copy that, put it here. Then I have response factor for CO2, which is here. I'm going to put it here. So what the software does actually, we just take the response factor column and multiplies with the sample error count of that peak, something like this. And then I'm gonna write the formula down here. Okay, so you have 20, 37, and 12. That could be in the report here. 20, 37, and 12 down here. Okay, and then for the unknown, it will depend on how you set the response factor for the unknown. In this case, let me show you calibration over here, calibration setting down here, and this is the section where it say calculates uncalibrated peaks. Okay, so usually it should be no over here, and where it's no, the software will not calculate anything for that unknown peak. Right, so there's no calculation, but this number still stays the same, 20, 37, and 12, which is the same over here. And so what I want you to notice over here is, so if you choose ESTD, whether or not you have unknown peak, these numbers will not be affected, unlike error percent, right? Okay, so the next one is normalized percent over here. So what does it do for that normalized percent? Let me demonstrate that. Go to specify report again, and you go to quantitation setting, normalized percent, and then say okay. Then you print the report. All right, so let me zoom on into the result table here. Okay, so what does it do for the normalization report over here? It's basically if we do one step after this ESTD external standard. So what does it do? It will take the total concentration based on ESTD over here. So that means you need to have a sum of this three, right? And then you have this one will just be this value divided by the total concentration down here. And then it will be the same thing for this, divided by the total here. And then this one will be this one, and divide by the total down here. All right, so there you have, and the sum of this should give you 100%, right? Oh, sorry. I need to add the equal over here, right? So sum of all this, and that should give you 100% down here, right? So it will be the same for the case of error percent. So if you have an unknown peak in your chromogram, in this case, I do have unknown peak over here, but because I didn't select, I didn't assign any response factor for that unknown peak, that's why there's no calculation performed. But if I'm going to choose response factor, let's say I assign the response factor for that peak is 1, then it will be calculated for me. So let me show you that. All right, so down here, there you go. You see the unknown peak over here. Then the response factor is 1, and then that will be equivalent to. So what the software does, it will be, let's say the response factor here is 1, and then what the software does, it will perform the ESTD here as well, and then you copy down here the formula, and then the total over here is no longer 70, 32, but it will be a total of all these four. So that means the number will change, right? So and then you have this. Be this one divided by this value as well. So for error percent and normalization percent report, you want to be very careful whether you have unknown peak in your chromogram or not, and whether or not that peak, those unknown peak are defined with whatever response factor over here, either using the use compound, whatever compounds you have in your cal table over here, or with the absolute response factor over here. So make sure that these are setting correctly, right? All right, so that's it, normalization report. Then you have ESTD percent report. This one is another step after ESTD. So what does it do for this one? I probably put some formula here so that's easier for you to follow. So that will be area divided by total area, right? So that will be a formula for this column. And then for ESTD, that will be response factor times area, right? And then normalization is basically ESTD divided by total ESTD. So that will be easier for you to, right? And then ESTD percent is another formula. In this case, ESTD percent will be ESTD times 100 divided by sample amount. Right? This is the formula. Let me do like this. We have some more space for you to see the formula, right? So that will be ESTD percent times 100 divided by sample amount. So let's try to do that. Okay, let's go here and choose ESTD percent out here, and then sample amount right here. If you define is 10, So let's put 0 first. So there's no sample amount defined over here. So wherever you don't define any sample amount in your run in your data, what the software does, it will stick back to ESTD. There's no calculation ahead of this one. Because this one is 0, it doesn't know how to perform ESTD percent. It will just keep the ESTD value, which is you see from here 20, 37, and 12, and 41. And that's why you get what you get from 20, 37, 12, and 41, right? So unless you put in the sample amount, let me put in that. Go back to this one. Then you put in the sample amount here, which is, let's say you put 10, for example. Okay, then you bring the report again. So right now the software will change the formula and it will apply the sample amount, which is 10 over here. Okay, so you have different numbers over here appearing. So what does it do? Actually, we take ESTD, which is this one. Take this one, and then times 100, and divide by the sample amount, which is 10, just how we defined it. So that will be like this. It's only percentage, so you need to times 100 over here, or actually you can just format this one as a 0 number like this. All right, so something like this. So that's how you get ESTD percentage. And let's compare with the value over here. You get 200% for CO2, for CO, and then for methane you get 378, 124 for CO2. There you go, and 417 for the unknown. Right. There you go. All right. So that is ESTD percentage. For ISTD and ISTD percent, they're a little bit more complicated. Whereas the first step, you may want to define the ESTD, which one is your internal standard. So that's basically you need to do over here. Just go here, select which peak you want to be as your internal standard, and just go here and select this one as yes. Okay. You key in number 1 for this one, and then for these two, you want to key in which internal standard you want to follow the calculation. So I will be using 1 for all of them. Right. All right. So if you are using ESTD, let me do that. So if you are using ISTD, Internal Standard Report, what the software does actually, we perform a couple of calculations using this. All right, so you have the internal standard as 10 over there, and then this is the number. So how does the software perform this calculation actually? So you see it's no longer amount divided by error, but it's only the ratio. So what does it do? So we need to perform at first, let me put something like this. It will perform the area ratio, and then the second one will perform the response factor ratio. So what is this? So let's do like this. So error ratio. In this case we choose methane as our response factor, so that we reference. So let me put this one will be CO and CO2, right? So for CO, that will be sample error divided by area of methane over here. Then for CO2, that will be error count of CO2 divided by error count of methane down here, right? For response factor, RF ratio, that will be a response factor down here. So CO divided by methane, and then down here will be CO2 divided by methane, right? So that's how you get, let me open this, right? So you have the error ratio, then you have RF ratio, and then once you have these two, the software will be able to calculate so-called the amount ratio, right? Amount ratio out here. So amount ratio is basically just error ratio times RF ratio. Then you get something like this. It's for the formula. You have the amount ratio, and because you have the amount ratio, in order for you to come up with the ISTD, then you will have this amount ratio times the concentration of the internal standard that you specify. And in this case, we specify the internal standard as, let me show you that. We specify internal standard as 10. So that will be 10 over here. And then will be the same thing for this one. This will be 10, right? Then you have internal standard. So let me show like this, and all right, something like this. And let's compare the value that we have in the Chemstation report. All right, scroll down here. Then what you have from here, methane, CO, you get 5.29. There you go, 5.29. And then CO2 you get 3.29. 3.29. There you go, right? So that's how you perform the calculation for ISTD. Okay, and then the next one is actually the last one, which is a little bit more complicated, where you have the ISTD percents. So wherever you see percent like this, basically what the software does, it will just perform one step further of ISTD. It actually will take, okay, percent. It will take the ISTD from here, time ISTD, time 100%, and then divide by the sample amount, which is very similar to ESTD percent on top here. And sample amount, let's say sample amount is 10 or whatever number we want, let's say 5, right? Then let me perform the same calculation from here, time 100%, divide by 5 for the sample amount. Okay, so we get this number. So let's perform that same calculation in Chemstation. Specify report ISTD percent, and I want sample amount to be 5. Okay, I say okay. And then what happened is I bring the report down here, and what do you get? Scroll down. Then I will get for CO, I get 105.97, 105.97 there. And then CO2 you get 65.85.7. 65.85. There you go. So that's how the software perform the calculation for every different modes over here, and that's how you can perform the same calculation using Excel. So understanding this will be very good benefit for you when it comes to let's say intelligent reporting, when you want to formulate your own calculation. So you want to make use of this calculation so that you will make the formula a lot easier in intelligent reporting, or at least when you use just normal classic report like this one, like this, then you know what the software does your calculation, right? So that will be very useful to understand all of this. All right, so that's all I have for you in this video. I hope you enjoy it, and let me know in the comment if you have any questions or any cases that you have no idea what's going on with your calculation. And don't forget to subscribe to my channel. Thank you very much for watching, and I'll see you in the next video. Bye bye.